welcome to week 2 of IT system security and encryption. This is going to be going over computer network-based threats instead of the other type of physical threats that I went over last week. This will be the other half of P1 essentially for you guys. So this will talk about sort of passive and active threats and also cloud-based threats that can occur on the network. And I'm going to try and be as detailed as I can. Now, this video is just going to be the quick overview of computer-based threats, and then I will go into specific detail on the separate videos. So, with that being said, I'll get straight into it. So, with this, it's going to be the second part, as I said. This will be a part of another 3 pass criterias, and then we will move on to the merit task. So once you've done these 3, we can start doing the merit task, and then there will be a distinction task, but that's also part of this part B, and then you can start doing the distinction task. So I'll start going over P2 and P3 in later weeks. So, as I said, computer-based threats, passive and active threats, and then I'm going to go over cloud-based threats. So, with computer network-based threats, obviously security threats can occur via actual internet or network. So, like I said before, it's not. That's one of the main ways of doing it because obviously it's a lot easier to do it over a network system than it is to physically go in and do stuff like social engineering that I talked about last week. Obviously, the way that they do this is through features of the Internet Protocol Suite, so IP addressing. Now, some of you will have heard of that. I'm going to go over this now to sort of show what IP is, so what an IP address is, how it works, and why. Obviously, a lot of attackers use this to get into networks and attack it. This is just a brief overview. I'm going to be going over it in more detail, but essentially each number, which you'll have seen before on an IP address, is made up of bits of data. So don't worry about it too much yet. We'll also go over it in architecture. So you don't need to know it for this P1 in particular, but it's useful to know this early on, just so you can understand how it's going to work. But obviously, it can be split into active and passive threats, and I have briefly talked about passive threats before, but hopefully, these set of videos you will understand how it's going to work. So, with IP addressing in particular, a lot of this is based around numbers that you've probably all seen before. So 192.168.1.1. Now you've probably seen this number many, many, many times before. So this is known obviously as a IP address, Internet Protocol address. And the way it works is it's the same as house addresses. So with a house address, and this is the best house you're going to get from me. With house addresses, as you will all definitely know, they have a street name and they have a number. So this might be house number 1, house number 2, house number 3. And they might be on something like, let's call it Rocky Road, because I'm craving that at the minute. So Rocky Road. How do you know how to deliver to, say, house number 1 on a letter? Well, you would probably put something like 1 Rocky Road. Oops, I can't spell today either. Let's get rid of that. Rocky Road. And then obviously any other info that's relevant. Same for a network, so if there is any other information that's relevant, it will be attached to it. But essentially, that's how you would deliver to number 1, right? So if you're delivering to number 1 here, you would put on number 1 Rocky Road because that's where it's got to go. Same with IP addresses. So let's instead use computers. And again, best computer drawings you're going to get from me because I am not very good at drawing. But let's do it anyway. So with these computers, these also have to have an address because how else can you find which one's on a network? With this, they will all be connected together, usually either via a router or by something called a network switch. And a network switch is basically a device that just has a lot of different Ethernet ports in it. So that might be Ethernet port 1, 2, 3, 4, da, 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 da. And usually there ends up being about 26 through to about 40 something on it. It depends on how many ports there are on the network switch, but you can connect that many computers to it. So with this switch, they'll all be connected and they'll all have an IP address. So this one, the first one might be 192.1, whoops, dot 168.1.1. This one here, let's just delete that at the top. So this one here might have 192.168.1.2, and this one 192.168.1.3. Now obviously you've probably seen already, but this last number is the one that changes, and that is the actual computer number on the network. So the last number will always change. So this number at the end, these numbers, is the one that changes. The first part of the address, so 192.168.1, these first three numbers are the actual network that it's on. So this whole network here is a part of this number address. So that is basically the road that it's on. If you add another network, so say let's connect this to the internet, and then you had this going off to another network, this network might be 192.168.2. Whatever for the computers. So if you notice, that number now changes. So the first three numbers will change for the... So these first three numbers will change for the network, and the number on the end will change for which computer device it actually is. That's how it works. So the first few numbers are the actual network number, and the last number, i.e. 1, so 3, 2, or 1, the one at the end is the computer number on the network, or device number, because it can be a printer, it can be a phone, it can be anything. Now, you might be thinking to yourself, well, what's the maximum number I can have out of this? Because, you know, computers can only go up to so much. The way that these addresses work, and we're going to go over it in architecture when we get onto architecture later, 168.1.1 for example, each of these are made up of 8 bits. So whoever's done architecture before and how numbers are stored, you'll already understand this. But if anybody's ever done binary before, the way binary works is if we have an 8-bit number, you'll have 8 digits. So this is 8 bits. Now, with binary, this first number here, if this turns into a 1, so we have 0, 0, 0, 0, 0, 0, 0, 1, that actually equals the number 1 in our sort of decimal number system. However, to get the number 2 out of binary, it would be 0, 0, 0, 0, 0, 0, 1, 0. That would equal 2. Because this first one here, that can either be 0 or 1, but it can only go up to 1. So after this, when it goes across, that 1 will now be 2, and obviously that will be 0. So this, when it's 1, will be the 2. So if you were going up to say 3, let's just delete all this. So 0, 0, 0, 0, 1, 2, 3, 4, 5, 7. That would be 3 because this is 1 and that's 2. So if you add them together, you get 3. So that number there is 3. But the way this works, so like I said, this is 1 and 2. So each number on a decimal system, binary system, sorry, not decimal system, binary system. So if we have 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So each number, so this one can either be 0 or 1. This one can either be 0 or 2. This one can either be 0 or 4, 8, 16, 32, 64, 128. So what this does is it doubles every time it goes down the line. So if you wanted, say, the number 10 in binary, it would be, you don't want 128 because that's too large. You don't want 64 because that's too large. You don't want 32 because that's too large. You don't want 16 because that's too large. However, 8 can go into 10, so you have that first. 4, if you add 8 plus 4, that's 12. So that's too much, so that'll be a 0. However, 8 plus 2, that would be 10, so you have that as a 1. And then obviously because you don't need anything else, the next one can be 0. So that in binary is the number 10. That's basically a rough overview. I will go over this in better detail when we do it in architecture, but that is how binary works. And for an IP address, they are made up of 8 bits. So with 192, so if we have as 4 number system, I've got 1, 2, 8, 64, 32, 16, 8, 4, 2, and 1. Now, what numbers go into 192? Well, that would, because 128 is big enough. What about add 64? Well, if you add 64 to 128, you actually get 192, which means the rest would be 0 like that. So that is what 192 is in binary, and the reason why that's used in networking is because you use only 2 bits of memory, i.e. them 2 bits out of 8. So that equals 192. So that's why it's 192. That's a common thing because it only uses 2 bits of memory instead of the whole 8. That's the reason. So these are both used. Obviously with 168, you would need to again add numbers together to get it. But if you look, 128 would be in it because that can be. 64 is too large at that point, so that would be 0. If you add 32, that would bring you up to 160. Let me just do my maths. I think that's correct. Yeah, 160. Obviously, 160 add 16 is going to be too high. 168, so that would be a 1 as well, because obviously that gives you 168, and then the rest would be 0, and that will equal 168. The main reason that this one's used for 168 is just because it's easy to remember, because it's 1, 0, 1, 0, 1, 0, 0, 0. It's just easy to remember from our point of view, like which bits it's using. And then obviously these numbers are going to be 0, 0, 0, 0, 0, 0, 0, 1, and then obviously the same for that one as well. So that's a basic rough overview of IP addresses and why they are them numbers in particular. So because, like I said earlier, what's the maximum number? If you've only got 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8, if all these were 1 instead, so all of them are being used, so 1, 2, 8, 64, 32, 16, 8, 4, 2, and 1. Well, what happens if you add all of these numbers together? So add all of them. Well, you get 255. That is the top number you can have. So the top number that can be right here can only be 255. So it's basically 1 to 255. That's the maximum number of computers you can have using 192.168.1. Now, you might be thinking, well, a network might have more than 255 computers. What happens at that point? Well, at that point, you would change how this works. So you would have, I'm not going to go into it because you don't need to know, but you can have a different type of network that basically, instead of using, let me just delete this. So typically, a small network where it has 192.168.1.1, we'll use these three as the network part of the address, and then this one as the computer part. So that's for a computer, and that's for a network. So pretty straightforward. However, what you can do, which I'll probably go over at some point in a later video, but for now, I'm just going to say that depending on what numbers you have, so instead of having 192, if you used more or less bits, so if you used less bits of data, let's say we go for a smaller number, say like 100, it might be that, so let's put 168.1.1, it might be that you use these two for the computer part of the address, and you might use these two for the network part of the address. I will go over this in more detail, but for now, just to stop confusion, work on the assumption that this address here, that's how networks work properly. So computers on IP addresses are defined by this part, and everything else network wise, so different networks are defined by this number here. So this number changes and goes up and down depending on which computer slash device it is, and this number goes up and down depending on which network it's actually on. That's been a quick overview of IP addresses. I say quick, it's been 15 minutes. Don't worry if you're freaking out thinking, I don't understand this, what is he talking about? Because I will go over it in class just to sort of get people to understand how IP addresses work. But know that IP addresses are used for basically defining what computers are which on a network, because that's the whole point. Obviously, without IP addresses, you won't be able to tell which computer is which. But for network threats, they basically work off IP address numbers and how you can sort of exploit them, and I'll go over them in different videos. So if you've got any questions about it, just let me know, and I'll talk to you in the week probably about it anyway. Bye.